Good afternoon, everyone. Today we're going to do a video out of the Calculus 12 curriculum on the product rule, where we're going to work through a few examples in detail, and I hope that I can figure some stuff out if you've been struggling finding derivatives of functions using the product rule. So we have two examples we're going to look at. Let's first of all run through the product rule and exactly what it is. So the product rule states that if we have a function f of x that is made up by the product of two functions that we can kind of separate, that is g of x times h of x. For example, we could have x squared, that could act as g of x, times sine x, that could act as h of x. Likewise, e to the 2x, that could be our g of x, and cos of 3x plus 1, that could act as h of x. So you see that they're kind of two separate functions brought together through multiplication, hence the product rule. The product rule states that the derivative of the entire function f of x, namely f prime of x, can be found by g prime of x, that is the derivative of the first part, times h of x, the original second part, plus g of x, that is the original first part, times h prime of x, times the derivative of the second part. Okay, so the derivative of the first part times the second part, plus the first part times the derivative of the second part. Okay, that is our product rule. So let's apply to these two examples. So first off, we have, for one, x squared times sine x. Okay, so let's call that f of x. Okay, then using our product rule, we find that f prime of x is going to be equal to the derivative of x squared. So let's call x squared g of x, and let's call sine x h of x. Okay, just so we can kind of refer to them using this notation. In that case, we're going to start with g prime of x times h of x. That is the derivative of x squared. The derivative of x squared using the power rule is simply 2x times the original h of x. So times sine x plus, now we have the original function, g of x, so x squared, times the derivative of the second part. The derivative of sine x, if you know your trig functions, is cos x. And so now, putting it all together, what we have is 2x sine x plus x squared cos x. Okay, and that's it. We're done. Okay, product rule has been used, and we have our derivative, f prime of x. Okay, that's it. So for number two, let's again take the time to break them up. Let's say this e to the 2x will act as our g of x, and cos of 3x plus 1 will act as our h of x. And let's call this entire function f of x. Okay? Then, if we take the derivative, f prime of x, we'll have g prime of x, that is the derivative of the first bit. The derivative of e to the 2x, remember, is the derivative of the exponent multiplies out front. The derivative of the exponent means the derivative of 2x, which is just 2. So the 2 multiplies out front, and so we have 2 e to the 2x. The exponent stays the same when we start differentiating exponentials. The exponent always stays the same, and the derivative of the exponent multiplies out front. And so the derivative 2 multiplies out front. The rest stays the same. Okay? We have g prime of x times h of x. So times cos of 3x plus 1 plus, next we have g of x times h prime of x. So we're going to leave e to the 2x alone, and we're going to differentiate cos of 3x plus 1. So I'll remind you that the derivative of cos of x is negative sine of x, right? So using our chain rule, because we have a derivative of a function inside of the brackets here, inside of the cos, so we're going to have negative sine of 3x plus 1 times the derivative of this inner piece, 3x plus 1. The derivative of 3x plus 1 is simply 3, and so we're going to have a factor of times 3. All of that being multiplied, okay? And so now if we want to clean things up a little bit, we'll have f prime of x is equal to, that first part is going to go unchanged, so we'll have 2e to the 2x cos of 3x plus 1. We'll have plus all of this, and there's a negative sign here. I'm just going to bring the negative into the sign, and have a subtraction symbol, okay? And I'll bring the 3 that came out of the chain rule out front and act as a coefficient, because that's a standard thing that we do. So we'll have minus 3 e to the 2x, now sine of 3x plus 1, okay? And now we could even go so far as to factor out an e to the 2x, right? We can factor out a little factor of e to the 2x. We don't absolutely have to, but it is something that I would recommend doing. And so to finish it off, our last line of work will have e to the 2x factored out of both terms because it's common to both terms. And then what we'll have left inside, we'll have 2 cos of 3x plus 1 minus 3 sine of 3x plus 1, all inside those brackets. And there we have it, okay? E to the 2x times this mad bracket, I forgot a little prime symbol here. And so there we have it. F prime of x, the derivative of f of x, is equal to this madness, okay? Oh, and I forgot another bracket. Goodness. There we go. 3x plus 1, and all of that is in brackets because we factored out an e to 2x. And there we have it, okay? I hope this helps. I hope this clears some things up with the product rule, and always remember to use the chain rule whenever it is necessary. If you have any comments, suggestions, please do let me know. Any requests for future videos, and thanks for watching.